Okay. Can you guys hear me online and in the room? Long time no see. Snip, snip. Okay. Did we all enjoy the long weekend? Did anyone do anything interesting? Good chat. Must have just done some comp work, I hope. How are we looking online? Is the slides right? The video's right? The audio's all good? Give me a thumbs up in the chat. Hamish, I'm not repeating that. Cool. Before we talk about today's lecture, I wanted to get rid of that. Get rid of that. Oh yeah, no, that's not what I want to get rid of. So just to remind you, I did post an announcement on this and I saw 300 people have watched the video, but sometimes in the playlist for the YouTube channel, it's got all the live videos in order. So the playlist is probably the best place to get all the videos. It's the 24T2 playlist. Because we missed, oh, the order's wrong. I got to fix that. But because we, oh, in fact, I can fix it right now. Because we missed the Monday lecture due to the long weekend, this sometimes happens and we do build in enough time so we don't have to worry about it. But so I recorded a 15-minute video on the really important stuff from the Monday lecture. So it's probably not in the same depth that the lecture would have gone into, obviously. So it's a bit more concentrated, but it's sort of everything you need to know in order to do the labs and tutorials this week and to help you with the content we'll do today. But I will do another recap of functions and procedures today. So just keep in mind that if you're ever looking for a video, sometimes we have these extra videos that pop up. The playlist is the best place to find it. And usually, like I did last night, I put out an announcement on the forum. So did you all get the email about the announcement? So I understand it wasn't a huge amount of time until right now, so I don't expect you to have watched it in time. But just make sure that you're aware of this. You're aware of, if you're listening to this right now and you didn't get an email, right, that's a problem. So if anyone didn't get the announcement email that this video went into the YouTube playlist, can you please post, well, I was going to say post on the forum, but that's stupid. Please email us at cs1511@unsw.edu.au, and we need to make sure that you're on the forum and you're getting the announcement emails. If you're just not checking your emails, can I really suggest that, even if it's just during term, you install Outlook or some email thing on your phone and you get the notifications, because sometimes we do send time-sensitive emails out. Okay? When's the lecture starting? Rude. I'm kidding. Punya. Okay. All right. So I think we'll spend still a little bit longer than usual doing a recap of the functions and procedures content. Who watched the video? What did you think of it? I tried a new system for, I don't know if you noticed, like the zooming and panning. Was it okay? Fantastic. Professional, he says. That's what we strive to be. All right. So if you've not watched the video, that's fine. Please do go watch it because it goes into some good detail and motivates why functions and procedures are important. But I will introduce them again now, but not as much time as we would because we need to get onto static arrays. Okay? So what is a functional procedure? If you think about all of the code we've written so far, right? We have probably hash include standard IO at the top. Yep. What else do we have? I haven't done that yet. Have I? I don't think I've done that. No, we have hash include standard IO at the top. Then we have int main. right? And then maybe return 0, and that's pretty much the skeleton of our programs. And if we're adding lines of code to our programs, where are those lines going, if you think about it? Into main, exactly right. So all the code we add to our programs is going into the main function, right? There's that word function again. So that doesn't scale very well, because essentially what that means is we have all of our programs executing line by line in the one main function. So that main function would get really, really long for a really long program. That doesn't scale. That doesn't work very well. What we want to be able to do, and one of the basic building blocks of programming, is having reusable blocks of code. So really simply, if we just take a step back and we don't get overly complicated, the idea here is some actions in code, right, are things that we want to do over and over and over. It's that simple. And what we do is we break those lines of code out into their own function. We give them a name, and then we can recall or reuse that logic over and over. So in another way of thinking about it, it's an abstraction. I use this word abstraction a lot. I know it's obviously very abstract, but it's really important. So if I say, go brush your teeth, you can think of that as a function, right? I'm not saying go walk to your bathroom, wherever you keep your toothbrush, which I hope is the bathroom, go put toothpaste on the toothbrush, go wet the toothbrush, do the circular motions. That would be too repetitive. But you brush your teeth hopefully twice a day, and if you don't, you should. So, especially if you're a comp student. So it makes more sense to give that repeated block of logic a name. And then twice a day when you brush your teeth, you just say, okay, I'm going to go brush my teeth. We do this all the time. We're giving a name to something that we do over and over, right? That's the concept. And the exact same idea applies here. We can call those functions multiple times just by using its name. So this makes a lot more sense when you have an example. So here's an example. This is 5 lines of code, right? I'm not counting the function declaration. So this is 5 lines of code here. What is that noise? Anyway, this is 5 lines of code that calculates pi. Italian. Speaking Italian. Anyway, sorry. It calculates pi. Reconnect. We can't see slides. Sure. How do you... Do you need to quit it and relaunch it? Oh, why is this happening? I was in a job interview once, so I was not interviewing, I was like on the panel. And, oh, here we go, never mind. You can hear the story another time. How's that? We're back? All right, we're back? Cool. Toothbrush is indeed not in the bathroom. Very good. Nope, left us hanging. Cannot see. Okay, they'll come up in a sec. Yeah, there's a delay. Okay, so here's 5 lines of code that calculates pi. Now, you might need to use pi several times in your program, right? We don't want to have to write out these 5 lines of code every single time we want to calculate this value. Forget the fact that you would just use a constant in reality, right? It's just an example. So what we do is we wrap that logic in a function. So that's the function declaration here. So we're saying, I want a new function, and what's the name of this function here? Pi, pi. So this part here is naming the function. The other component we have is the type that goes before the name of the function. And for someone who watched the video, what does this represent? Who was that? And where? What did you say? So the student says the type of the variable being did you say recalled? I think the word is returned, but absolutely correct. So pi is returning back. It's calculating a number. Pi is a double. So we say that this function returns a double. So we're giving some information about the function. So functions always return back something. There's a little asterisk there that we'll talk about in a second. And again, we use a trusty block to say everything in this block is part of the pi function. And if you notice, if you've got a keen eye, this is exactly like main. Int, main, brackets, block. Right? So main is a function. You've been writing functions already. Okay, great question. What goes in the brackets? You know, I maybe should get up the... Okay, you know what? Let's just do that. Can you read this or should I make it white? You can read it at the back? No. Oh, that was an interesting way of saying we can read it. Thumbs down. All right, let's just leave it like this for now. So here I've got a function. This is the code from the video, so that's why it's here. Here I've got a function. What's the name of this function? The name of it. Print Pokemon is the name of it. What do you think this function's job is? To print a Pokemon to the standard output or to the terminal, okay? Some functions require information for them to do their job. And that's what goes in the parameters. That's what goes in those brackets. So if your job is to print a Pokemon, what do you need to know? The details of the Pokemon that you're printing, right? But if your job is to calculate pi, you actually don't need to know anything. Pi is it's always the same value. So you just need to do the calculation. So in this example, there is no input. So it's all about understanding what is required for this function to do its job.
Why have you written void print Pokemon? Like, isn't that a type of object field?
Okay. Some functions do something, in this case print, but they don't actually return anything. So there's still a return type, but it's void, which means nothing. So that's why there's no return on this function. So this is all in that video, that the functions and procedures video. I go into detail on all of this. Forward declaration, I'm going to leave for you to watch in the video. I don't want to spend too much time on it. It's a simple idea that just helps us write more organized code. Okay. Let's write another little program that shows off functions. I think that, thumbs up or hands up if you want me to change this back to white, or do you prefer it as black? Who wants white? And who wants keep it? I think keep it one there, sorry. All right. Oh, you'll notice, I guess this is the moment it's happening. I'm no longer going to write the lecture code in VLab. I'm just going to write it locally on my machine. If you notice, sometimes I'm very clumsy with the keyboard shortcuts. It's because this is where I write code and this is where I'm more comfortable. You can continue doing whatever it is that works well for you. All right? All right, so I've got this program here, int main void, and it returns 0. It's pretty classic. So I can put some code in here like printf, hey, whoops, don't forget the semicolon. I am a program. I don't know, what are you? So this program's got these 3 lines of code. And if we compile the program, I'll just zoom that out a bit. Hopefully you can still read that. Oh, I gotta save the file first. And you can also notice I'm using a different C compiler here. You should continue using DCC. So if I run that program, I get those 3 lines of code printed out. Now let's just say, for whatever reason, I want to do this many times, right? I want to print this function many times. I would need to copy the 3 lines and put them and repeat them, right? So like this and like this. But that's repeated code, and that's not what we want to do. That's annoying. So the idea of functions is, here's some useful code that we want to do, we want to call over and over and over. Let's break it down into a function. So let's create a function whose job is to just repeat these 3 lines. So let's think about it, right? What are the building blocks for this function? So we need to know, what information does a function need, and what does it give back, and what does it do? So does a function that prints these 3 lines need any extra information? Someone take a guess? No. Why not? Yeah, there's nothing. Every single time this runs, exactly those 3 lines will get printed. There's nothing else going on, right? It's a really simple example. So if we know that the function doesn't need any input, and we know it doesn't return anything back, it means it's a void function. So now we need to give it a name. I'm going to just call it print message. And we just said it needs no input, which I agree with. The body of this function is going to just print, whoops, those 3 lines. So here we've created the print message function. Now, if I want to call that function, I just use the name of it. Whoops. And a semicolon at the end. Now, I just recompiled and reran this program, and the exact same output gets printed. So let's think about this sort of closely. In C, where do our programs start executing from? From main, that's right. So we jump to main, and then the first line of code is this call here to print message. So what happens is we say, okay, print message, that is a function that I've seen before. It was declared over here. So I'm going to jump into that body and execute the lines of code that's part of that function. In this case, it's just 3 printf statements. The function ends, we come back to this point in the code, and then we return 0, so we end the program. Okay? That is a function. It's that simple. The reason it's so cool is now I can just call it 3 times, right? And I get it printed every time. So now I have this one label to perform some useful function over and over. Now this is not a very useful function, I'll admit, right? So we can modify it. So we can say something like, am happy. That could be an int, and happy. So let's say we want some Boolean to determine whether or not the message is going to be happy or not, right? So I'll annotate this. A function which prints a message zero if sad, 1 if happy for that input. So now we have a way to give extra information to the function. And depending on what the value of that variable is, we can do something different in the function, right? So I can say, if am happy, so if am happy is set to true, I can maybe print, hey, my good friend, how are you on? Right? Else, What's the message going to be? Don't be mad. Else we print some message like this, right? So now, depending on the input to this function, we're changing what we do. And every time we call it, right, that function will run with that input. Now, we've got some issue here. If I compile this just the way it is, what's the issue going to be? Someone yell it out while I do it. Too few arguments to the function call. Okay, what does that mean? What we're saying here is this function has an argument, has input. It's an integer. So when we call the function, I need to give it that integer. And the way we give it that integer is we just put it in order of the parameters. So let's say the first message is going to be happy, happy, sad, sad. And now the function's happy. Well, that was unintended. Now the function, there's no syntax issue with this function because we're passing in this integer which maps over to this integer here. So now the function has this value, am happy. See, the first time it runs, we're getting the happy message, the happy message, the sad message, the sad message. But look how clean my main function is, right? Imagine if I didn't have this function, I would have these lines of code times 4. I am still repeating myself here, and I could put this into a loop. But it's not as bad as 5 lines, right? Yeah. Any other questions? Is it making sense? Who's comfortable with what we've spoken about? Cool. For those of you who are less comfortable, please go and watch the functions and procedures video. I think it does a slightly better job of setting up why they're useful. In the program? And remember, this is a function that doesn't return anything. Some functions calculate values and they return them. It's all discussed in the video. Did you get what you needed from this? All right. Okay. So that was functions and procedures, a super important topic. Now, probably one of my favorite topics of introductory programming, arrays. I think 1511 is very front heavy, right? We introduce a lot of concepts. Pretty much every lecture is a new concept in the first few weeks. The benefit to doing it this way is that by about week 6 or 7, we're pretty much done with concepts, and then it's just practice. So bear with us, but arrays is, I think I say this every lecture, but another one of these keystone topics that you'll be using for the rest of your programming career. Anyone want to just tell me what the word array means in plain English? Like a set? I mean, sorry? An ordered set, he says. That seems like a synonym for an array, more than an explanation. Anyone online? What's an array?
In simple terms, it's like a group of stuff, usually of the same type.
Yeah, a group of stuff usually of the same type. Sometimes you hear it with a satellite array. Has anyone heard that term? So you have a bunch of satellites out in a field. Sometimes they're called satellite arrays. It just means you've got multiple of one thing. So far in our programs, when we create a type and we create a variable of that type, we can only store a single item in that variable, right? So if we go over to this program, if I create an integer here called x and I assign it the value 5, I have the memory in my computer to store a single integer in the variable x. Right? We all agree with that? If I want a second integer, what do I need to do? New variable. If I want a third integer, new variable. Okay, and now this is getting tiring. What if all of those elements, right, 5, 10, 15, what if they're all part of the same entity? They're related. So what if we wanted to store many values in a single variable? Right? At the moment, we have no way of doing this. So here's a good example. So let's say in my program, I want to represent how many times I visit Messina for the 7 days of the week. Right? So on the first day I visit it twice, or I eat 2 ice creams. On the second day I visit it 3 times. On the third day I visit it 3 times. Right? It comes back to this problem again. Does this seem repetitive? It seems repetitive. All I want to store is the number of times I visit Messina in the week. I don't want 7 separate variables. There's another issue with this program, other than it being repetitive, right? And that is that I have 7 different variables when all I have that I care about is one thing. Does that make sense? So this was 7 variables. What if I wanted the variables to track every day of the year? Right? We don't want 365 integer variables all spelled out in our program. That would be horrific. And many variables will not always be efficient. Okay, so I want to pause here for a quick second. If you're on the YouTube chat, please, in fact, why don't we do a poll? Can someone do a poll on the YouTube chat? Wait, I can do it. Add a poll. So if you're in the room, you can also access the poll, or you can just throw your hand up. Is this problem making sense? Is it motivated? Yes? Yes? Good? Okay, we got 89% yes. Good so far. 100% yes. How did that go up? Anyway. So we don't want, right, 365 integers being declared here. Whoops. So this motivates arrays, and this motivates a broader topic called data structures. If we could just keep the noise, I can't see where it's coming from, but the noise down over there. Okay. So in programming, we have these ways of storing structures of data, not structs, structures of data, data structures. Usually, especially in this course, when we talk about data structures, we are storing the same type of data in each element. Okay, that'll make more sense in a moment here. And they scale, that's really important. I can store 7 integers in a data structure. I can store 7,000. I can store 7 million without 7 million lines of code. So data in COMP1511, we talk about 2 data structures, arrays, which we're talking about today, and linked lists. In fact, these topics are so important, these are the 2 hurdle topics on the final exam. So in order to pass this course, on top of needing a score of greater than 50, you need to prove to us that you understand arrays and linked lists, which we aren't talking about today, in good detail. That's how important these topics are. Basically, what we're saying here is that you can't go into future comp courses right? If you don't understand arrays and linked lists. They're that powerful and that useful. All right, so let's talk about arrays. They are a collection of data, all of the same type, and the word for that is homogeneous. So that means that every element in the array has to be consistent in type. So that's one thing. Another thing is we get a single identifier for the entire array. So if I want ice creams eaten, that would be a single identifier, and that identifier could store, for example, 7 integers. Okay, and this is super important. It's a random access data structure. Does anyone happen to know what this means? And then I'll answer your question. Anyone want to take a guess? Maybe online? Where have you heard random access before? And not just the Daft Punk album. RAM?
Hard drive storage.
Hard drives are not random access, but RAM is random access. That's what it stands for, random access memory. Yeah, we've got this idea of sequential access and this idea of random access. So let me really simply explain it to you, right? If I have something that's sequential access and I want to access you in the middle row, sequential access means I need to start over here and go through every single person until I get to you. That's sequential access. Random access means I can just go straight towards you. Okay, you know what? Actually, I've just come up with a better example. Let's say I want to get to you there, right there. If it's sequential access, which it kind of is, I need to start there and walk through the row. If it's random access, it means I can like drop in from the sky and just like lapel down and like, I don't know, kidnap him, right? That's the difference. So sequential access, you got to go through to access something, and random access, you can jump straight in. So if you think about CDs, you know, I don't know, probably now they've never used a CD. Who's used a CD before? Oh my God, amazing. If you want to access track 7, so CDs are they random or sequential? So if you want to access track 7, what do you need to do?
Keep on pressing forward.
Yeah, you got to start at the track 1 and skip to track 2, skip to track 3, skip to track 4. So tapes, old VHS tapes, are sequential. You got to read through them. A USB stick is random access. The computer can jump into any piece of memory directly.
Does it not have to go through folders to jump into the specific memory?
The way we represent a USB stick is with folders, but the actual mechanisms behind it. For example, if you want to play track 8, CDs are maybe a bad example because they're so fast. But has anyone used a VHS tape? 4, 5, 6 people. If you wanted to jump to an hour in on the movie, anyone remember what you had to do? And it would take a while. Yeah, you'd have to hold fast forward. Yeah, you'd have to hold fast forward. Yeah, it's like YouTube 2 times. That's a better translation for the Gen Zers or whatever you are. Yeah. But a USB stick, right? If you know the file you want to open, it's just how long it takes to open that file. You don't have to sort of scan through anything. Does that make sense? All right, so arrays are random access. Random access is fantastic because that means it's fast. Now, if we're storing multiple elements, oh yeah, there were questions. Sorry, you're right. Good point. Up here. Okay, the question was, what does homogeneous mean? Don't laugh. I mean, it's not a common word. The only reason I'm laughing is because I said the word homogeneous. And homogeneous means, so do you know what the word homogeneous means? It's fine if the answer is no, it's not a common word. It just means everything is the same. So in one sense, you are a homogeneous group of people because you're all Dead? No, you're all alive, and you're all COMP1511 students. So in that sense, you're all homogenous. If I went out to the quad, you would not be homogenous because you're all from different courses. But you're not homogenous in terms of gender or height or anything like that. Moving on. Is it really? Maybe it's whatever. Sue me. Good comeback though. Good recovery. There was another question? There was another question. I remember the hand.
Why is it called random if you can like choose it? You know, it doesn't just like when I select on a USB, it doesn't give me a random file.
Okay, that's a good question. Guys, keep the notes down. Why is it called random? It's not random in that when I read a file off a USB stick, I get a random file back, which is clearly not the case. It's random. Yeah, I actually don't know why the word is random. Angela, do you know? Why random? Why not just like anywhere? I don't know. Yeah, I don't know the history behind the word. It would come from RAM, I'm guessing. It could come from mathematics. Who knows? If someone wants to find out and let me know, post it in the chat, that would be cool. But it doesn't really mean random. It means I can jump in directly anywhere. But random's just a proxy for the word. Good question though. Any other questions?
It comes from the fact that it's not sequential.
It's not sequential. Therefore, it's random. I don't know. Yeah, thank you. Good point. All right. Yeah, maybe that's it. Maybe Xeno Online, it's just RAM is like a nice word. RAM. It's like the animal. Okay, let's move on. Few more minutes and then we'll break for Kahoot and stuff, right? Let's just stay focused. This is really important. So, okay, I'm introducing another word that's hopefully spelled correctly this time. So if an array is multiples of a data type, like integers, what's important is that I can read, that's meant to say read, so there is a typo, read or modify individual elements. So for example, 7 days of the week, 7 ice creams. Oh, Brianna, do you have a marker? Watch Angela. Oh. Thank you. Right, so if I have my ice creams, right, 2 ice creams, 3 ice creams, 0 ice creams. I was on a diet that day, 1 ice cream and 3 ice creams. So this is how we typically represent arrays when we're drawing them out. It means I can individually, because they're random access, I can change this element. I can read this element out, right? I don't have to handle the entire array. I can use it to access individual elements, just like they were individual variables, right? Does that make sense? Okay, and it's a contiguous data structure. What? What?
You still have to put like 7 different numbers, right?
If the array stored 7 elements, I would need the 7 values in there. Well, sort of.
It's not very different to just writing 7 ints.
It is different because there's 1 variable here, whereas you would need 7 variables. And what if I had 500 elements?
But you still have to put in 500 different values.
I don't actually need to fill them all out. They can stay empty. Yeah. Okay. Why is Jake screaming? I'll try not to scream. So what does contiguous mean? So this looks kind of similar to what we have on the board. This is how I think about arrays in my mind. Programming, let me give you a hot tip here. Programming is all about building a mental model for code. Your mental model might look different to mine, but it's important you come up with something. So this is how I think about arrays. You can see it's pretty much what I drew on the board. So I've got the index, so it's just the position of each element starting at 0. And I've got the value, so what actual value do I want to store in the elements? Static arrays, which is what we're talking about today, have a set size. So when I create a static array, and we'll look at the code to do that soon, we tell it how big we want it to be. So how many elements should be in that grid, in that list, in that array. So if I have an integer array, in this example, how many integers am I storing? 5, because you remember, don't get off by 1 from the 0. So this stores 5 integers. An integer is typically 32 bits. So what happens when I ask for a 5-element 32-bit integer array is I get 32 bits multiplied by 5 back. So I get 160 bits of memory. Remember, there's nothing, it's all memory at the end of the day. And the other really cool thing about arrays in C is that they're so efficient. So there's no extra memory required to store an array. So if I had 5 integers, it would be 160 bits as well. That's not true in other languages. In other languages, if I have an array, it actually needs more data than the size of the elements summed. So this is what makes C so efficient. Now, we got to explain this idea of contiguous. And I think I've just come up in my mind with a way to do that. There's no eraser. Yes, there is. So this is the ice creams array. The alternative to the ice creams array would be, in this case, 5 integers separately, right? I'll just call it X, Y, Z for now. If I have these 3 lines of code, the operating system will create 3 pieces of memory for integers, correct? Yep. But here's the difference between this and arrays. With these 3 separate integers, right? If this is my big pool of memory, what's the difference between the 2 examples? So
The second example takes up more memory because it's creating 3 different.
pretend this was like this. So pretend it's the same amount. They're not separated. That's exactly it. And that's what contiguous means. Contiguous means all of the elements are in the same block of memory. So the arrays are contiguous. Right, do you see it? It's 0, then the first element, then the second element. Whereas separate integers are not contiguous. So the operating system will decide where the variable goes. And it will be a different position. It won't be next, it might not be directly next to the previous one.
Are they actually physically stored like next to each other?
In an array, they are, well, okay. Good question. So the question was, are they physically stored next to each other? The answer, let's just say the answer is yes. They are physically in RAM, like on the like they're electronically next to each other. It is possible that some memory architecture does some funky optimization, but you would never know it. Yeah. In all reality, they are next to each other.
What if there isn't enough space to put them next to each other?
What if there is not enough space to put them next to each other? There will be enough space, or there is not enough space for the program and the program will crash. Yeah, that's something that the operating system will handle. You cannot have an array in C or any contiguous data structure that is not next to each other. And I'll talk about why that is, maybe we'll talk about it today. Any other questions? Why does it matter? That's a great question. That's a great question. If I asked you, to come down to the board and I asked you to point to the variable z, you would have to know the memory address of z and follow it to the variable in memory, okay? That's why the variable c needs to be its own variable. If I then asked you to find the variable y, you would need to know the memory address of y. So with the 3 variables, how many memory addresses do you need to know in order to access the 3 pieces of memory? 3, all right. If I give you an array that's a contiguous data structure, and I say I want you to tell me the value of the 3rd element, and I've guaranteed to you that it's contiguous, what do you need?
1 address.
Let this guy out. 1 address. Because you know where it starts, and you know how far along it is. And so you can just start here and say, oh, I want the 3rd element, which is going to be 1, 2, 3. So how many memory addresses do you need to store all 3 elements? 1. And that's why it's so important that they are contiguous. Did that answer your question?
So that means if you have like an array with 5,000 elements, you only need a single address.
Exactly right. If I have an array with 5,000 elements, I only need a single identifier, a single address, and then I just move over 5,000 times. Or move over the amount worth 5,000 times. We don't actually move 5,000 times. We're getting a little bit ahead of ourselves here, but these are fantastic questions. All right. So here is the actual syntax for creating a static integer array. So the cool thing is that it's really similar to creating a single integer. So the first thing we have here is the type, and this is the type. Where's my pointer gone? This is the type of what? What's it the type of? Don't say integer. What is it the type of? There's a specific answer I'm looking for. It's an integer array, but what is it the type of? Every element in the array. It's the type of, it's not an int. This is not an integer that we're creating here, right? It's 7 integers. So because arrays are homogeneous, spelled with an E, it's describing the type of every element in the array. Then we have the name of the array, which is ice cream per day. So that can be whatever you want. And then we have this syntax here. So not much syntax that just describes the size of the array. Square brackets, how many elements?
That can be like any integer number you want.
It could be any integer number that you want. You cannot put a decimal number. Doesn't quite make sense to store a non-whole number of elements. So that would be a syntax error if you did that. Right? So how many bits do you get if I ran that line of code? Quick maths. 7 times 32, which is, I don't know. Oh, someone fact check that. Nice, that was impressive. All right. Now, this is an array declaration. There's no values being assigned here, right? So how do we assign values to those 7 positions? Well, there's a few ways to do it. So C actually gives us a shorthand way of doing it, and that's with the curly braces. So this will assign 3, 2, 1, 2, 1, 3, 5 into each element of the array, right? Here's an important note. You can only do this when you're creating the array. You can't do it later. Here's another shorthand initialization. If there's nothing in the curly braces, It actually just puts zeros in there, in every element.
Can you fill it up later, like each of the?
We can still change them later, but not like this. Yeah. In fact, I don't know why you can't. I don't know why you can't do this later. If anyone knows, maybe Angela knows. I don't know why they don't let you just do ice cream per day equals this later on. There must be some limitation in the compiler or something. I don't know. Okay, good question. If you put more than 7 values, I think it'll be an error. It's worth trying. I can't quite remember. It's not something that you typically do. However, a better question, or another good question would be, what if you put less than 7 values? If you put less than 7 values, it copies in the amount you've got, and then the rest will be zeros.
So does this only store integers, or can it store doubles?
This can only store integers because the arrays are homogeneous. So the type here is what the elements will be.
So I can make that a car or.
We could change this to a double, but every element will be a double. Yeah. It would. So the question was, will it throw an error or will it round if you assign a double to one of these elements? I think it will do the exact same thing as if you assign a double to an integer, in which case it will round. But that's because doubles and integers are technically compatible types. You can round from a double to an int.
What if you put in a character?
Characters and ints are also compatible because characters are ints. So you would get the ASCII integer of the character assigned in. Okay. So this line of code at the top, right, we talk about mental models, creates something like what you see at the bottom. In memory, you will get enough space for 7 integers. They will be right next to each other in the same block of memory. And those integer values, 3, 2, 1, 2, 1, 3, 5, will be assigned. Right? Pretty simple. Thumbs up. Fantastic. Do we want to leave it there for a quick break? And then come back? I think we'll come back. Either we finish the topic or do the Kahoot, I don't know in what order, and then we will continue on. Sound good? All right, go stretch your legs. I think I will finish off these 3 slides on arrays, then we'll jump into the Kahoot. Oh, the coffee orders are in. Very good. I was caving. What does caving mean? Do you mean like exploring caves? Anyway. You go down in the ground to look at some rocks. Yeah, that sounds awful. All right. All right, let's finish off these few slides on arrays and then we will jump into the Kahoot. And I remembered the Pokemon cards this time. All right. We're good online? Awesome. Thanks, John. Okay. Why don't we actually pause here and jump into some code demos? Let's jump into some code demos on how we can get started with arrays, all right? So if you've got your laptop here with your VLab opened, you might want to follow along. Guys, let's just get the noise down, please, so we can get started, please. All right. Okay, so let's just do a quick recap. If I want to create an integer, what do I type? Int, the name of the integer, so like ice cream, and I can assign it the value 5. All right, that creates a single integer in memory. An array of integers is really similar. So it's the type of element in each item of the array. The name of the array, I'm going to call it ice creams. And the difference is I need to tell the compiler how many elements of the type integer I want. And the way we do that is with that square bracket syntax we had a look at and another integer here. So that right there creates 7 times 32 bits of memory. This one is how many? Just 32 bits of memory, because an integer is 32 bits. There's nothing in the elements, right? They're still empty. I've not assigned any values. So maybe to make it consistent, I'll do that. But right there, those 3 characters is quite a big difference. It goes from a single integer to 7 integers, all with a single identifier, a single variable. Any questions so far? All right. We need a way, we said arrays are randomly accessible. So we need a way, how do we actually access individual elements of the array? And the way we do it is with using this index. So by using that, it's the exact same syntax as we use to describe the length of the array. I can use it to describe which index in the array I want to access, okay? So the 0th index is going to be the value 3. The index of 1 is going to be the value 2. The index of 2 is going to be the value 3. Right? So if I've got some array like this, and I want to assign the value 5 to index 3, what do I do here? So did you say int? So int, we've already created the array. Now with my created array, I want to access the third element. So I don't need to use the type anymore, right? So I just say ice creams. Then what were you going to say?
I'm not sure now.
That's fine. So ice creams is the name of my array, and I want to access index 3. So I use that same notation, index 3. And I can assign it the value 5.
What if we do this about like with the squiggly brackets thing and just put 0, 0, 5 and then 0, 0, 0?
So the question, let me not answer that right now. Let's just stay here for a second. So here's another example, right, where I'm using index 0. So I'm saying go to my array and access the 0th element, or that first element, and then assign it 5. So I'm changing what's in this piece of memory by using this notation. Okay? So I want to write a bit more here. So let's delete that. 7 integers in my array. I want to assign the value 5 to index 3. I've done that here. Let's actually assign values to each of the 7 elements. And for now, we're just going to forget about that curly brace notation. So what do? I say ice creams of 0. The first element is going to be, 1. Well, I mean, that code alone is fine. So what's this code do? Someone else? Sets all 7 values of my array to the value 1. Exactly right.
Wait, is ice creams 7 long or 8 long?
Ice creams is 7 integers long. So there's 7 integers. So we have indexes 0 through to 6, which is 7 elements. That arrays are always 0 based in C. It will cause issues now and then. All right, so this is how we access each individual element. The question is, can you have an array of any data type? And the answer is pretty much yes. Even structs. I can have an array of structs. I can have an array of arrays. So the question is, can you use a negative number in the indexes? And the answer is no, not in C. Yep. But does this make sense before we move on? So I create some array. The array has indexes. The index matches over to a piece of memory. And I can read and write to those individual indices. So if I right now wanted to change the index 3 to no longer have 1 ice cream but to have 5 ice creams, how can I do that? Someone yell it out as I type. Exactly right. Forgetting the typo.
Can't you just show up and then
Oh yeah, I was just pretending I wanted to change it after. Yep. Does this make sense to everyone? All right, cool. Okay, so now let's say, rather than these values being hard-coded, I want to ask the user of my program to tell me how many ice creams they ate. All right? So I no longer know how many ice creams. So if I want to read that integer in from the user, what do I need to use? Scanf, exactly right. How do I scanf an integer? %d, comma, and here I would typically have the variable that I'm scanning into. Now, let me actually do a printf here. Enter your ice creams for day, let's say day 1. So I want the user to tell me how many ice creams they ate on day 1. So what variable or what piece of memory would I put here? So, so ice creams or ice cream square brackets 0. So if we think about it, if I want ice creams for the first day, this is the element for ice creams on the first day. So that will scan an integer from the terminal into, not the array, into the 0th element of the array. Do you see that?
Why wasn't the ice cream tool scanner in
Oh, another good question. Why don't we need an ampersand for arrays? The answer will come in a future lecture. Sorry. Yes, is that right, Angela? You look concerned. Oh, you do? I mean, you're probably right. It's been a while since I've done this. Let's double check that. Oops. Actually, and then let's also just printf %d and 5 gets printed. Let me just, I think you're right. Yeah, cool. So you still need the ampersand there. It's exactly the same as a variable in this case, right? So if you were scanning into an integer, you need ampersand and the name of the variable. Okay, good catch there. All right, so enter your ice creams for day 1, and I can do that. If I wanted to do it for day 2, what would I do, everyone? I would repeat the code. I would say day 2. And what would I change here? 1, because that is the second element. All right. And then this would print them out. 4 and 5 get printed. All right, so this works. This is how we handle arrays. We can access individual elements, we can read those individual elements out, print them out, handle them just like integer variables, right? But this sort of motivates what we want to finish up with, which is arrays. But actually, before we do that, we're going to do the Kahoot. Just realized. Let me learn from my mistakes. Do it on this screen first. Ah. Should I do 3.1 or 3.2 Kahoot? Yeah. No, this is on functions. And this is on... I think we'll do... Do you want to do a Kahoot on structs and enums or on functions? Functions, you think? All right, screw it. What is this? Should we? I don't know. How are you moving around though? Screw it.
No way.
I have no idea what this is. Probably ruined the Kahoot now. (6280629) is the code. Let me get the lecture chat back up. That's up to 40 players. What? No, the 75. Oh no. First, no. All right, how do I quit? Sorry. How do I quit it? Wrecked. Thank you, Musical Wizard. Is there one that doesn't have a... Oh, it says it there. Update 100, 40, 200. Is 200 enough? Oh. Do you want to do teams? No. All right, fine. All right, if less people start coming to the lectures, we can do one of the 200 ones. But that wouldn't be good. All right, 2395723. Thank you, Musical Wizard, for spotting that. Someone's paying attention. And why don't I get the audio? No, that's not good. There better be more than 200 in this Kahoot, otherwise we could have done the robot thing. Or the other one. But hip hip hooray, your mama, very nice. Sheldon Cooper. Yes, thank you, Brianna. All right, ready to go? Anyone need a second? Jake Rosella, least original name ever. We get it every term. Ooh. All right, let's just start. That's enough. All right. So remember, this is on functions. So if you did your homework and watched the video, good for you. So functions help us do what? Group-related instructions, reduce the amount of code we need to write, can compute a result and return to the caller, or all of the above. Yes, yes, yes. If there's an all of the above, it's pretty much the right answer. So I suppose in some way none of you are wrong. All right, true or false? Functions always do exactly the same thing. The guy in the green sweater, I see you're not happy with what you've done. Oh, okay. '83 said yes, functions always do exactly the same thing. Although most of you said false. Why is the answer false? Sorry? That's a good point. So you could have if statements within a function, but I suppose even then it would always do the same thing given the same circumstances. So why is the answer false? There's another reason.
What if you have a variable?
You could have input into functions which changes what they do. So that's why the answer would be false there. So we can control the way that our functions operate. We need to import a library to use functions in C. By library here we mean, hash include or whatever. Ooh. So who said you need functions? Libraries, sorry. So why did you say yes? Yeah, so you need standard input output to use printf and scanf, but you don't need it to use, say, main or to create your own function. So some functions are behind libraries, but you don't need a library to use functions in general. So a question, or you just nope? That explain what went wrong there? All right, pasta on top there. Question 4. To call a function called fun in C that requires 2 input arguments, which are integers, how would you declare that function? Guys, Who was yelling? It says to call. It says to call. Is that you? Yeah. To call a function in C. Right? Not to declare it. The other hint here is that we never told you the return type. So you wouldn't know what type it returns. So it wouldn't be able to be orange. When we're calling a function, we don't specify the type. We just give it the values. So it can't be red. Blue, those are types, so it can't be blue. It's definitely not orange, so the answer is green. Who got it right? Well done. All right, question 5. What parameters would go in to those 2 slots on line 1? Very good, very good. So we are passing into that function a and b, where a is an integer and b is a double. Therefore, it makes sense that the function would be defined as int a double b. So int a double b is the correct answer there. What data type is returned by the function called mystery? All right. Who said it was a character? Why? Because it's returning the character Z, but what's the return type of the function? So what will happen if you return the character? It will get the integer representation of the character Z. So we'll turn that character Z into the ASCII, and the ASCII for Z is what? I can't remember. What is it? Is it really? Yeah, it's higher than that, isn't it? I don't believe you. Lovely. 122. Oh, is that what you said? I thought you said 22. Sorry. I believe you. I don't know why. I'm just fact checking this. Yeah, 122. I thought you were saying 22. I was like, no, that's not right. So that will return 122. All right, what is a function prototype in C? Someone clip what? Oh, I said declare. Whoopsie. I'm just testing you out. What is a function prototype in C? Oh, well done. I mean, it's sort of in the question, isn't it? But okay. What is printed out on line 12? Okay. 3 plus 7 equals 0. So let's break this down. Did you get it right in the white t-shirt? You got it right? You didn't get it wrong. You got it right. What do you mean? You got it wrong. Oh, I thought you were celebrating. Sorry. I can see this is a little confusing, so let's break it down quickly. Sum is a function which accepts two integers x and y. It adds them together and it does return the result, all right? So that would return 10 in this case. However, result is initialized to 0. We call sum, but we don't do anything with that result. To get 3 plus 7 equals 10, we would need to assign the result of sum back to result. So this would have needed to say result equals sum xy. Does that make sense? Without that, we take that 10 and we just discard it. So we get printf d plus d equals %d, which would be 3 plus 7 equals 0. All right, and then final question. What is printed out on line 10? Let's have a look here. Int x, int y, x equals 4. Ooh, good question. All right. Why is this one 54? 24, sorry. Who got it right? You got it right? Don't look away. Why is this one working? Oh yeah, that. So yeah, so x is being reassigned here, which is probably a sign of a broken function, to be honest, because you're ignoring what's passed in. But forgetting that, why does the result get printed? Whereas in the previous example, the result wasn't printed. Because the result of it is being substituted from the call. So we're calling something, the result is being returned, and that return value is what's being printed.
Would that code actually work? There's no ampersand in front of the function.
This is not an array.
So yeah, and it's not a variable because it's a function that doesn't need.
Okay, I see what you're saying here. Yeah. If a function returns something like this one does, it returns an integer. If I call that function, you can think of it as you go off, you run the function, you calculate the result, and that result gets substituted for the call. So you could do either like int x equals something, or that function call here will be printed.
If I did print f is %d divided by n, comma, and then 24, would it print the same thing?
Yes.
Oh, okay.
If 24 is what something returns, yes.
Yeah, okay.
Yeah. That is what that's doing. It goes off, it runs something, it gets the integer, and you can think of it, it replaces that with the literal integer. Yeah. All right, let's do the podium. And then I think Pastor in third. Segfault in two, and I think I know who's first. I do want to make a comment here that let's keep this course to computer science, but for the future names of your accounts. Remember, there's a lot of people in this course, and we want to just be conscious of that. All right, anyway, well done on the podium. Congratulations. Round of applause. All right. And I've got the Pokemon cards, so if you want to come up to me after the lecture and collect those, you can do that. Alrighty. Some people playing on touchscreen devices, so they don't have to use the mouse. See, that's the min-maxing that we need to do here. All right. Let me close this. Open this. All right. So where did we leave this? All right. Shake off the Kahoot. Better luck next time if you didn't place. All right. So we spoke about arrays, collections of data. We can access individual elements of the array. All right. And in this program, I want to ask the user to tell me how many ice creams they ate each day of the week for 7 days. And you can see here, right, that if I want to do this for the rest of the program, day 1, day 2, day 3, day 4, so on, I would need about 2 lines of code, so 14 lines of code to do this. But we keep going on about that repeated code is bad. And if you look at this code, does it look a bit repetitive? Right? That looks repetitive to me. So when we deal with arrays, by the nature of an array, we're dealing with repetition because you're storing multiple elements of the same type. Right? It's another way of thinking about it, it's a repetition of a data type. So it's super common when we talk about arrays that we also deal with them with loops. So loops and arrays are close friends. So here's that example we were just talking about. And we were saying it looks repetitive. So in this example, the 7 elements have been initialized with the 7 values. We're printing them all each. But this doesn't look nice to me. This is one of these code smells. If you look at these lines, the only thing changing is this integer. And when we see something like this, the alarm bell should ring in your mind to say, hey, we can simplify this with a loop. And here's how we can do that simplification. So instead of accessing each element one by one and then printing it, I can loop over the indices. So that index 0, 1, 2 becomes the integer I, which is what I use to print, and then I add 1 every time the loop runs. And I've simplified all of those lines of code down into a loop. And of course, the benefit here is that this is 7 lines, but this could be 300 lines. And again, all I would need to change here is 7 to 300. So let's take our program, which instead of printing the ice creams was reading them in, and change this to use a loop. Cool? I will hide the terminal for now. So what is the lines of code that's being repeated? It's lines 8 and 9, 11 and 12, 14 and 15. So I can wrap these 2 lines of code into a loop. Right? So how do I create a loop? I say while, well actually first I need to define my index counter, I, and I say while I is less than, and here I typically put the size of the array, so 7. And then I have the body of my loop. So every time this loop runs, if we add 1 to I at the end, I will start at 0 and go up until 6, because 6 is less than 7, but 7 is not less than 7, right? So remember to add 1 to I at the end of each loop. And then I can just take those 2 lines of code and place them in my loop. So now every time the loop runs, it's going to print and ask the user to enter the number of ice creams, and it's going to scan that into the element. Now, I can't leave it like this, right? Because this 0 is hard-coded and this 1 is hard-coded. So what do I need to replace those with?
Another variable like J.
Another variable, you say? I is my index counter. I don't need it. This isn't a 2D loop. It's a one-dimensional loop. So I can just use I.
How do you account for the off by 1 error when you're using the print function?
Like here?
Yeah.
Yeah, let's talk about that in a second. All right. So we want to change this to no longer always print day 1, but to print day I. And the way we do that is really simply replace this with %d, right? And pass in I. Now, humans think in one index spaced, computers think in 0. So the first day, I don't want it to be 0, I want it to be 1. So I just take I and add 1 to it. That's it. And this line down here, I don't want to always scan into the 0th element. Which element do I want to scan into? I, because I will represent each of those elements. And then we add 1 to I at the end. That's it. And then I get to delete all of that code, which is a fantastic feeling. Programmers think the point of programming is writing code. Probably the best part of programming is deleting code. That's usually a sign that you're doing things right. All right, should we run this? So enter your ice creams for day 1. Let's say I had 5 ice creams, then 1, then 2, then 3, then 5, then 6, whatever. Enter them for day 7, and then the program ends.
Is there a way to set it up such that it all comes up at once and you can navigate between each entry? Like, let's say you want to enter ice cream from day 4 first. Could you get them all to come up to have scanning, whenever you type it in?
Everything's possible, but for now we're going to keep it simple like this. Yeah. The question was asking, I didn't quite get your question. Can you start at day 4?
Your ice creams for day 1 and then have the scan into length and let the guy or girl input their
But isn't that what they're doing?
Because you have to do 1, then 2, then 3, then 4, then 5.
So you have a question.
Oh, you want them to choose which day. I understand. Let's see if we get time at the end of this lecture, we can do that. All right. So we're assigning those ice creams into the elements. How do we know that they're actually being stored? I mean, okay, someone online has just said it. How do we print the total ice creams at the end of the code? So let's do that. And let's do it properly with loops. So we've assigned all the values in, we've read all the values in. Now what we want to do is print all those values out. So I can say, let's set I back to 0, and let's just copy that loop. And we can say, on day %D, you ate %D ice creams. Whoa. So what should I pass in for the first element? I plus 1, very good. And the second element? Ice creams I, exactly right. Right, because when I is 0, it will read the first index in the array. When I is 1, it will read the second, etc. And this will prove to us that the elements were actually being stored in, because that's how we're printing them out. Now, the sort of annoying part of this is that we're going to need to enter in 7 elements. I'm just going to do 1, 2, 3, 4, 5, 6, 7. And look at that. We loop through and we can access each individual element and print them straight out to the terminal too. And that is the power of arrays, and especially with loops. Now, one thing we should probably do to this program to improve it is to take that hard-coded 7 and replace it with a constant. Let me replace it to 14 days, 2 weeks. Ooh, fancy. So now anytime I had that 7, I've replaced it with num days. And in one change, right? 14, now it could be 20 days. I could do 3 days, as long as I recompile the program. right? We're changing how much memory we are creating on the fly. Can you explain why you did I plus 1? Okay, easy. I mean, yes, the answer is yes. I starts at 0, and on our array indices, we start at 0. Right? So the index starts at 0 in C. Arrays are 0-based. But the first day, day 1, if I'm talking English, is referring to where the index is 0. So I'm adding 1 to go from 0 to 1 when I print it out. Did that answer your question, Hayden? I think it was already answered by the time I just explained that. Thank you, Brianna. Cool. Any other questions on arrays? That's it for this lecture, by the way. Okay, oh, that's a great question. Let's do that. Well, so your first question was, how do you print the entire array? This does print the entire array, right? Yeah, you could just change what this is. Like this could just be %d space comma, right? Is that what you mean? Right, that is printing the entire array. This is actually really worth doing. So one quick thing I want to do, why don't we calculate now the average number of ice creams that I eat? Or actually just do the total. So the total ice creams, how would we do this, right? We have this array of integers. I want to find the total. I'm going to create a variable which stores that total. And every time the loop runs, I print out that number. And I can say that the total number of ice creams is equal to the current total plus the number of ice creams on the ith day, or on that day. And then just when I finish the loop, I can print out that variable. So 432, and then the total is 9. And that's very powerful. So I can also do the average. Will that fix it? Anyway, I ran through that very quick. You can access the code. Brianna, do you happen to have the lecture feedback URL? No, that's wait. If you have the feedback, please, there's the QR code. If you've got any questions, feel free to come down. I don't know if the next lecturer is here.
I'm like practicing the